Hi, algebra students. So our next topic is going to be a complete Desmos topic. So there's nothing you really need to write down on paper for this. We're just going to need Desmos in order to type equations in and then be able to interpret them. And actually, I call them equations, but we're actually starting our unit on inequalities. And so I'm going to bring up a quick presentation just to remind you what an inequality is and how it is not actually an equation. Inequalities, if you'll remember from 6th grade and probably last year, inequalities have to do, or you're going to see the greater than and less than and greater than and equal to or less than or equal to signs in your math problem. And so probably in 6th grade and even last year, you saw inequalities that look like this. Again, you don't have to write this down. I'm just going to remind you how we would normally see this, and we would solve it just like we would an equation. The only thing in the end is there's going to be a greater than symbol. So you would do the steps like normal. And we would get 2x is greater than negative 2 minus 4 is negative 6. And then you would have divided by 2. And you would have gotten x is greater than negative 3. And so again, if you'll remember from last year, you would go and find negative 3 on the number line. Because it's just greater than, you would circle and draw a circle on negative 3, but you would not fill it in. If there had been an equal to sign under this, then remember you would color this in. But in our case, we do not have that. And then we would shade, right? And so since this says x is greater than negative 3, we would shade along this number line everything that was greater than negative 3. And then we would maybe ask ourselves a question, or maybe you would be asked a question after that. And so below here, if you'll notice, I've got a question that says, is negative 1 a solution to this inequality? And we would say, yes, it is a solution because negative 1 is included in the shaded region. And so again, that's just a quick review of what maybe you have done in the past. So what we're going to work on today is, this is what we would call an inequality with one variable. So everything that you've worked on up until now only had an x in it, or maybe a y, but it would only have one variable. And so today, some of the examples that we're going to look at actually have two variables in them. All right, so let's look at some inequalities that have two variables. So what we're going to be looking at this week is a graph that is y is greater than negative x plus 3. Now notice that these equations have an x and a y in them both. And they're also very close to, or at least this one is, very close to what we have been working with is y is equal to mx plus b. So what's going to be true about this type of inequality is it is going to have a slope. Notice the slope right here is negative 1. And it is going to have a y-intercept 3. And again, the nice thing about this is that we are going to be able to type this directly into Desmos and see what it tells us. All right, so I'm going to flip over to Desmos. Remember, the equation is y is greater than negative x plus 3. So go ahead and open up your Desmos if you'd like, and maybe pause this video so you can type this in with me. So the equation is y is greater than. Now you can type that in from your keyboard, or you can also go down here to the keyboard and type in, right here is your less than, greater than or equal to, less than or equal to. So you can type it in from the keyboard down here as well, or click on it. Negative x plus 3. Now you're going to notice some bright colors show up on your screen because what this is doing is this is graphing the inequality of, first of all, the line that is being represented, and we just said it's a slope of negative 1. So notice it's down 1 over 1, down 1 over 1, down 1 over 1. It does have an intercept of 3 right here. However, instead of being equal to, with what we would normally see, a line, there's no equal to sign here. It's everything greater than this line. So again, if you can imagine this being like a hillside, think about which side would you be standing on and that would be greater than you. Well, if you're standing here, the sky is above you, right? So and this would actually be, if this were a mountain, this would be the actual solid mountain. So it's shading everything greater than this line. Now, I want you to notice one other thing. This line is dashed. It's dotted. See how this is broken up? There's like little gaps here. If I were to change this symbol, it's just greater than right now. If I were to change it to greater than or equal to, notice it makes it solid. And I want you to take a second and think why that would be. Oops, let me type that in again. Let me type in our original. So there's what we're starting with. There's our problem. Think about why that would be. Because when you just say that something is greater than something else, you are not including the actual thing, right? What this is saying is everything greater than this line, not the line itself, but everything that's greater than. And notice, even if I were to zoom out and like go way up in here to cyberspace, everything is shaded. Like everything that's greater than it. Except for that line. We're saying everything that is bigger than this line. Now, when we change this, if we were to change it to greater than or equal to, now the line is included. Now the line is solid. So we're saying that everything that is either greater than this line or equal to this line. So it solids it out, or it makes the line solid. And that's going to be important when we start thinking about solutions to this problem. So the first thing you're going to just need to be able to do is type this into Desmos and recognize the graph. So on your practice, you are going to be asked to look at some graphs and say which graph matches this equation. All you're going to have to do is type it in and notice, is it shaded above or below? Because also notice what would happen if I change this to less than. You could probably guess it's going to shade everything that's below the line. Let's go back to our original problem. So the first thing we want to make sure that we notice is that if it's less than, or greater than, it's a dotted line. If I were to change that to a solid line, if I were to change that to greater than or equal to, it's now a solid line. Even if I were to make it less than or equal to, it would be a solid line. And we just want to be able to recognize the graph. Now, that's easy enough, but then we want to ask ourselves some questions. So let's go back to our original questions. And so here's the graph that we have looked at. We know what it looks like now. The questions are, and it gives us an ordered pair, an x and a y value, remember. Is this a solution? So our points are going to be 2, 5, 1, 2, and negative 1, 1. And we just want to know, is this a solution or not? So let's go back to Desmos. And I'm going to type in the point 2, 5. That's the first one that we're checking. All right, so you can type it in. And the nice thing about Desmos is that it actually graphs it for you. You can click on it. There's what 2, 5 is. So when we're thinking about what is a solution to this inequality, we're thinking, is it included in the shaded region? Is it included in the shaded region? So for 2, 5, the answer is yes. That point is included in the greater than the line part of the graph. It is included in the solution. So if it's in the shaded area, yes, it is a solution. So we're going to say yes. All right, what about 1, 2? So let's go back to our graph. We're going to type in 1, 2. Actually, I'm going to leave that one. I'll type it in below 1, 2 so we can still see that one. Now, this becomes a really interesting question because is this included in the shaded region? Well, remember, we're saying everything greater than this line. And this one actually ends up being right on the line. Even if you're to zoom way in, you can tell it stays on the line the whole time. It's not like a little off or a little below or a little above. So is this included in the solutions? Well, no, it's not in the shaded region. And it's on a dotted line. Anything on a dotted line is not included. Remember, we're only looking for things that are greater than this line. So this is not greater than this line. This is the line. This is on the line. And because it's not solid, we cannot include it. So we're going to say no, this is not a solution. Now, you have to imagine, though, if this line had been solid, so if this problem had a greater than or equal to and it were solid, then it would be a yes. This would be included. So solid lines are included. Dotted lines are not. If it lies on the dotted line, it's greater than or equal to. So you can include dots that are equal to on the line. But in our case, it's dashed. It's a dashed broken line. And so no, it is not included. It is not greater than that line. And then the last point that we need to ask ourselves about is negative 1, 1. And so again, you can type that in, negative 1, 1. And notice that that point is way over here. It is not greater than the line. It is not included in the shaded area, and so it is not a solution to this graph. And those are really the types of questions you're going to be asked. Number 1, to recognize the graph and see what it looks like. Type it in Desmos. Number 2, to answer, is a point a solution or not? And if it's in the shaded region, it is. If it's on the line and it's dashed, it is not. And if it's not in the shaded at all, it is definitely not. Let's look at another example. So an equation that's not in y equals mx plus b form, but that's okay. Desmos does not mind if we do that. So I'm going to clear all of this out. So again, you're going to see the problem. And the problem here was 2x minus 4y is less than or equal to. I'm going to come down here and get that. You can also type in, if you type in less than and then hit the equal to, it'll change it. But I just like going to the menu and typing in less than or equal to. -8 is the problem. All right, so let's double check, make sure we got that. -2 minus 4y is less than or equal to -8. Yep, make sure that you can type that in on Desmos on your computer. Make sure it looks the same as mine. I'm going to hit the home button to just reorient my zoom and make sure I'm zoomed correctly. All right, so notice the shading color has changed. You can actually click and turn it off, or you can actually click and hold right here. At least you used to be able to. Thought you could change it, change the color. Maybe not. Oh yeah, there you go. Click and hold and you can change whatever color if you want it to be purple or anything. All right, anyway. So again, notice we have a line here. Notice because it is less than or equal to, we have a dashed line. And we have everything that is less than this. Now, again, don't think too hard about which way is less and less and greater, because notice that we do have, like, on the x-axis this is going up, but the y-axis this is going up. But remember, we also have less numbers going to the left and less numbers going down. So it will shade it correctly for you. It just depends on what your equation is and what form it's in. So we have our shading, and then we will be able to recognize the graph. We'll be able to see what it looks like. And notice again that this is a solid line. So if we do end up with a point on the line, it is going to be included as a solution. So let's look at the points that we're asked about for this one. So we've got our graph. We can recognize it. Now we have 4, 3. Is that a solution? So I'm going to go here. I'm going to type in 4, 3. Is this point a solution? Answer in your head to yourself. No, it's in the white space. It is not a solution. It's not in the shaded area. So for that point, we would say no. Is -1, 1 a solution? So again, we'll type this in, -1, 1. Is that a solution? No, that is also not a solution. It is not in the shaded area. It's not even on the line. So that would be a no. And 6, 5. So let's look at 6, 5. 6, 5. Is 6, 5 a solution? Well, it's on the line, and we have to ask ourselves, is that line included? And yes, because it is a solid line and not a dashed line, because we do include it in being equal to, it is going to be a solution. So 6, 5 is a solution, yes. Now, look at that graph for just a second and name me a point. You can even type it in and check it if you want to. See if you can find a point that would be a solution also that is in the shaded area. So you have lots to pick from. I might pick something like -4, 2. That would be a point that was in the shaded solution area. So anything that's in the purple up here is going to be a solution, but also anything below, not. Anything that's on the line will be in this case because it's a solid line. All right, just a couple more. I want to show you what a one variable solution looks like when we type it into Desmos. And so this is just x is greater than 1. And so we're going to look at what does x greater than 1 look like. X is greater than 1. Now remember, a single variable is going to create a straight line in Desmos on the coordinate plane. And in this case, it is shading everything that is above x equals 1. So here is where x on the x-axis equals 1. We draw a straight line through it. Notice it's dotted, dashed, because it does not have the equal to sign. So it's not a solid line. So anything on that line is not going to be included in the solution area. But everything over here will be. And so we'll check our points. 5, 6. So let's type in 5, 6. 5, 6 definitely is yes. -1, 2. So I'll type in -1, 2. -1, 2 is definitely not in the shaded area. So that would be a no. And what about 1, 10? So 1, 10. And we'll have to zoom out a little bit because I can't see it. There it is. 1, 10 is the green dot that we see up here. It's on the line. Is it included in this solution? It's not, because it's on the dotted line. It's including everything that is above x equals 1, and that is not above. It is on the line. And so a dashed line, again, answers will not be included. All right, so that one would be a no. And last example, and then you're going to go practice this. Again, just the same thing. Nothing really to work out, nothing really to write down, just typing them in Desmos and asking sort of analysis questions. So the next problem here is going to be y is greater than or equal to 1. So notice that it has changed. Let's make sure that, oh no, less than or equal to, I'm sorry. We'll notice how the shading is going to change when I change this to less than or equal to. So less than or equal to, it shades, it goes to y, where y is 1, so on the y-axis, draws a straight line through it, shades everything below the graph, and it is a solid line because I am including, it is equal to. It's everything less than that and equal to. And so we're going to check a few last points here. So we got 1, 2. So 1, 2 is not a solution, not in the shaded area. So no. 5, negative 6. 5, negative 6. And we may have to zoom out a little bit to see it. Yep, there it is. It is a solution way down here in the shaded area. So yes, that is a solution. And 9, 1. So let's look at 9, 1. You can probably guess that it's going to be actually on the line. So we find a solution. It is on the line. Is it included this time? Well, yes, this is all points that have y is less than or equal to 1. And this one is equal to 1 in the y area. And it is a solid line, so it is included. Solid lines are included. Dashed lines are not included. All right? And so that is our inequality instruction for the day. This is actually a pretty straightforward unit. We're going to do inequalities like this for a while, answering questions about inequalities. We're going to answer some questions about systems of inequalities where we would have 2 of these. And then that's pretty much this unit. Is inequalities is just being able to type it in Desmos, recognizing what the graphs look like, and also picking out solutions. So your practice is available and ready. Let me know if you have any questions. Make sure you use Desmos for this, for practicing inequalities.